co-host.
Hey. All right. So today we're going to be covering CAD modeling. CAD stands for Computer Aided Design. And specifically, we're going to be working with Fusion 360. So there's a ton of different softwares out there. I think the most common ones that we would probably come across are AutoCAD Fusion 360, SolidWorks, and Creo. SolidWorks is my personal, what I'm personally best at, just because of like all my classes have used it. But once you know one, you kind of get the theory behind the rest. So it's just a matter of getting familiar with the different styles of the software. So the reason I didn't do SolidWorks today was mainly because like it was just a longer download, and it's a little bit less intuitive for beginning use. It likes to pop up errors if you aren't fully defined. And yeah, Fusion 360 is just better for like if you're throwing together a quick sketch and you just want to get it out of the way. So cannot minimize Zoom when you're recording this meeting. Oh, share screen, I guess. Alrighty. So here we have Fusion 360. Hopefully this bar doesn't get in the way. Alex, do you know if there's a way to move this at all? If I need to reach something, or do I just need to move this down? Sorry, you're muted.
Woo! There's like 3 little dots on the top right of that bar, or like it says more or something like that.
Okay.
On the top right, and then it says hide floating video bar or whatever. You can click that and that'll get rid of it.
Okay, cool. So yeah, this is Fusion 360. It's pretty chill, like I said, if you just want to throw something together really quick. Sometimes the way that the items are nested is a little bit non-intuitive, because rather than organizing like, body part, it kind of splits between the bodies and the sketches. And I'll show you what that looks like more later, so you can see what I'm talking about. Let's see if there's anything else. Yeah, it's pretty nice because it has its own built-in cam and like drawing softwares. There's a ton of different uses for CAD modeling. The most predominant one, I guess, for us would probably be just to get an idea of how something looks. Getting out the dimensions. If you want to have a digital drawing, usually you would like to do CAD, and then the CAD software has some sort of branch that lets you like just kind of like print the specs from different angles. See anything else? Yeah, it's good for FEA, finite element analysis, if you're like testing stresses, CFD if you're going more into like the aerodynamics, and CAM if you're going into machining it. All right, so first things first, you want to create a new file. I kind of already have one open here. It's untitled. Good practice is to save first thing, just so that you know that you have something. So AS practice, I guess. And then I'll save that under a folder that I made called AES. You can also access this if you say like the show data panel, and it kind of shows you what your current projects are. So I created an AES project file to open, and so that has what I currently have. Also through this, if you click that home button, it goes back, and you can go down and kind of see samples if you want to work through practicing on your own time. All right, so I figured a good first practice thing that would kind of get you a feel for this would be designing a cone. So here, there's solid, surface, sheet metal, and tools. So tools is more of like if you're going into like the CAM region of like machining, creating a tool path. Sheet metal, it's a pretty nifty tool. I personally don't use it a ton, but if you're like, I have a flat sheet and I want to bend it X, Y, and Z ways, you can model that as well. Surface versus solid, my understanding is that it quite literally means like, are you just showing the outside of it, or are you modeling like the body as a whole? So I would encourage to work within solid. And of course, if you wanted to work within any of the other software attributes available, you can go down here and go into like the simulations, manufacturing, drawing, etc. All right, so first I'm going to go here to create sketch under solid. And also notice that there are drop-down bars that offer different options later down the road. So I'm going to create sketch, and then it wants you to select a plane. So this is going to be like kind of coming from the top, whereas these are going to be along the two sides. So this would be like X, Y, Y, Z, X, Z. So I'm just going to click on the bottom plane here. You can also see in this top right corner, it kind of shows you what face you're working with, and you can easily click around to change what angle you're looking at it from. All right, so first I just kind of want to go over your create tools, just what all of these things mean, because it is a lot to take in if you don't have a ton of experience with it. So line is just going to draw a line. Rectangle, circle, arc, polygon, all these ones with like these little menus on the side. That just means that there's different ways of defining it. So for example, if you're more concerned about where the edges fall, you might be wanting to do a 2-point or 3-point rectangle. Whereas if you're more focused on where the center lies, you would want the center base drawing. You can change the dimensions and constraints later to fit where you want it to lie, but just for like quick sketching, it is nice to have those options, to have it generally in the right location in the first place. So yeah, there's all these things. Slots are just kind of like if you have two holes and you connected them in between. Spline is almost like an arc, except there's more directions to it. You can create a point if you want to define something specifically. And then these tools down here, I'll get into later. As for modify, so fillet is like if you have a sharp edge and you want to round it. Trim is if you have overlapping lines. So if you're like, oh, I want to create the circle, but then I want like, you know, almost like if you were doing like a T-shaped slot and you wanted to have like, oh, circle, circle, lines connecting the circles. But you can't just create those circles because otherwise it confuses the software. So you want to erase like the internals of that, let's say. Extend extends to a surface. So if you accidentally trimmed a little too much, you can fix that. And then offset is another nice one to know. And that just means like, obviously offset from whatever you're drawing. Now, as for constraints, this goes into defining your model. So generally you want your model fully defined. Sometimes there are some exceptions to this, usually when you're working with assemblies, but I would not encourage working with large assemblies in Fusion just because it does get a little complicated in keeping track of everything. The software was more designed for like small assemblies and quick drawings of parts. So yeah, constraints deal with like defining where points lie. So if you want something coincident versus equal, like that's kind of saying like, oh, if you want an overlapping tangent, you see this little circle with a line. So if you had a circle that you wanted to lie tangent to a line, you can do that. I think they pretty much are self-explanatory. You can like just do a quick Google search if any of them are confusing you. They're good things to know, and oftentimes if you're trying to move a part and it's not working with you, the first thing that you want to check is the constraints, because generally there's a constraint that you forgot about that's not allowing you to shift something from where it currently is. You'll see that a bit more in the future. So first I'm going to start with a center diameter circle. Just place it over here at the origin. and draw outwards. And then do that one more time with a slightly smaller circle. Just so that we have like a cone reference, I kind of brought up a couple different models that I found online. This is in millimeters, and this is in I think millimeters as well. I actually didn't check this one. So this cone, let's say, is, yeah, it goes to the base. So let's say it's about like 85 millimeters. So, and then the diameters are going to be 205 and 183. So if you go here to the create and you click sketch dimension, you can define what you want your length to be. I believe that if you type it in different units, it will convert it for you. So if I'm like, oh, 1 inch, it takes it to 1 inch. If you want to change what units you're working in, click on your name in the top right corner and go under preferences. We're going to be working with millimeters here, but I do want to let you guys know how to use this. So you want unit and value display. You can change what precision you want. This isn't going to be super applicable unless you're just kind of sensitive to like, oh, I don't want to see too many units. This is more for if you're like machining, wanting to show tolerances. And then yeah, you have your default units. I think you need to be out of the drawing to edit that.
I found in on the main screen, there's like the document settings thing, and under there it has a thing for units. I think it's just per document.
Okay.
But
yeah, default units is more like if every time you open it, you want it to show up like in inches or whatever. Okay, so just going back to this drawing. So we have the outer diameter is 205. So you can double click on it to change it. So if you just click 205, it will assume the default units, which in this case for me is millimeters. And then the smaller one is 183. So you just click the outer circle 183. Oh, also, I forgot to cover this. Most CAD softwares use this, but generally it's nice to have a mouse if you want to be able to shift around easy from different views. Just because like with the way that it's integrated, so left clicking is going to be, oh, sorry, you can click escape to deselect, yeah, or do this. So you can left click to like select a feature, or you can like off click to like deselect or click escape. Right clicking, it does some sort of sketch thing. I'm not sure exactly what that's about, but if you click on the scroll wheel and you drag it, it will shift your view. And then scrolling in and out is how you zoom. I meant to cover that basic control, but it's good to know. Also for these, like if it's like kind of showing off screen, because I dragged it far out, you can just drag it back in. And so you're going to notice that these lines shifted from being blue before to being black. So like, see how that's blue? So what blue means is that it's an undefined sketch. So as long as it's blue, you can still like drag it around. Defined just kind of means like, yeah, well, defined how much detail has been given to its dimensions and its location on the overall plane. So yeah, when it's black, that means that's fully defined. usually, from what I've experienced, like in my small time with Fusion 360, it seems like it's a little less touchy about fully defining than SolidWorks is. So that's just like another good feature of this. If you wanted to like click on it and like click delete, then you could mess around with it and you could kind of be like, oh, you know, I can drag it inwards or outwards. That's another good test too. If you're like, why is something undefined? If you just kind of pick on the blue piece and drag it around, that usually shows you which direction it's not defined in. All right. So now that we have these two circles, you can go ahead and finish the sketch. Drag it slightly off so that you can kind of get a sense of how it lies spatially. And you're going to want, I think it's under here, modify. So if you click modify, go down here to move copy. It also has the shortcut M. So if you just click your M key, it will automatically go to this. So I think for you guys, it automatically has bodies selected over here. So that's if you've already like extruded a part, basically. We're only having this little cone here. So we're gonna want to click sketch objects. And then you can select these. So you can select either the inner one or outer one. I'm gonna choose the outer one, and it gives you these little axes here that you can drag along. It also has the option to change it over here. What you're going to notice is that it should preview when you're dragging it around, where you're dragging it to. And notice how it's not doing that here. So the reason that that is because you have a constraint, assuming that you did what I did and placed it at the origin. Usually when you place at the origin, it kind of assumes that everything's going to be based around there. So while this is constrained to the origin, I can't move the edges around to do what I want to do. Like I said, I'm making a cone here, so the method that I was going to use was just lofting, which basically means that it's going to like kind of follow along a path, not quite in the same way as what's that called? As sweeping. Sweeping is more if you have like a tube structure, whereas lofting is more if you have like the outer shapes for like more of a cone type shape. So to fix that, you're going to go over here on the left, click the drop down for sketches, click on the right click on this, and then click edit sketch. It'll automatically drag you to be perpendicular to the plane looking down. And so you want to make sure on the right you have show constraints available. So yeah, if you kind of like put your thing over the origin and you kind of see these two symbols right here, it's showing the coincidence symbol. So it's saying, oh, these circles are going to be coincident to the center. So you want to just click on those and click your little delete button. So I believe that is. So finish sketch, and then try moving again. Make sure that it's selecting sketch options and select, for my case, I'm going to do the outer one and drag upwards. And you can define the specific amount that you would like to drag. So I was saying like, oh, I want to do about 85 millimeters here. So that will show that. Looks like I do need to redefine the inner one. Ah, I see. So yeah, I'm just gonna go back and edit that sketch real quick. Okay, so it was just the angle I was looking at it with, it appears. So when you're out here, you want to go under the solid section. And so extrude basically moves something outwards. It can also be used inversely with hole, which creates a hole through the object. revolve is more for if you're like doing something about an axis. So you could technically do revolve to make a cone, but you would have to define the angles and everything. So it's just a little bit different in its definition process, and it's a little bit less straightforward. So you want to click that drop down and then go down here to where you see loft. And so it's going to ask you to define this loft. So here we have the profiles, and you just want to click the two little faces that you had and click OK. And so that will create a little cone. This isn't super wide because I chose the 183 diameter, not the 100. So if you would like to change that, you can just go back in the sketch, change it, and it will change the dimensions with you. So I want this to be 183, and I want this to be 100, I believe. So now you get more of a cone shape. Now you're going to notice that this is filled in. So there are ways to go about that. What you're going to want to do is come under this modify tab and select shell. Shell is basically for hollowing things out. So hole creates like a hole through something. Shell hollows something specifically. You're not necessarily selecting the depth that it's hollowing. You're more selecting like what the perimeter, what the thickness of the walls are going to be. So when you're doing this, you're going to want to select the top face. If you want the cone to be hollow on the bottom as well, so if you want this to be like an open cone versus like only the top's open, then select the bottom as well. And so selecting these two faces is basically going to say, okay, we're going to create like a shell inwards from these two. So the inside thickness, you can do 0.05, let's say, something pretty thin. It allows you the option to select the direction. So you can do it outer, inner, both. Yeah, that's pretty self-explanatory, but basically it's what direction you want the thickness to go. So if you're concentrated on like, oh, I need the outside to fit within the space, then you want an inside diameter. If you're saying, oh, I want to make sure that the inside of this cone, the inner diameter is a certain amount, then you can select the outside, because then the inside is the diameter that you defined in the sketch. If you select both, then it kind of splits it down the middle. That's not super useful for like more precise specs, but it is nice to have for certain applications, just not necessarily shell in this case. So after you do that, as you see, it has the preview. You can click OK. And so now you have this little cone. It's cute. If you would like to do something in addition to this, I was thinking like if you were like, oh, I have this, let's say, speaker cone, and I would like to create the bolt holes on the outside of the top. So you can go ahead and create another sketch. And so initially the sketches only gave you the option to sketch off of these three axes, right? Of course, if you defined your own axes somewhere, or if you move those axes, you can base it off of that position or offset from those locations. Now that we have a body in here, we can also define based on the body. So if I like scroll in real tight here, where I have like the top, ooh, I accidentally selected the wrong one. I'm gonna delete that. Yeah, I probably should have made this a little bit thicker. However, you have this top plane available. Gosh. Okay, it's being difficult, so I'm just gonna make that thicker, I guess. All right, so this is the part where I do prefer SolidWorks over this, and maybe it's just me not knowing the full functionality. So I want that thickness to be wider, right? I'm just gonna quickly delete the body and recreate that. It hid the sketch, so you can redraw that, and then loft. So I'm gonna make that like maybe 0.1 thickness. Is that visible? Let's make it thick. Let's make it like 0.5 millimeter. All right. So I'm gonna sketch, I'm gonna define the top of this as this plane. So now everything's gonna be based off of the top of the cone. You can, I believe it's under create. So you already have the sketch, and you don't necessarily want to be redrawing circles every time, or not even circles. You don't want to be redrawing the edges every time that you want to create something overlapping on something else. So you can work off of the face, but you can also convert entities. That's what's called in SolidWorks, and here it's called project include. Project include. And basically that says we're going to define this line that was part of a different sketch as being part of this sketch as well. So it's pretty handy. You don't have to redefine everything with that specific geometry. So you're just gonna go ahead and select that. I'm going to select this inner one, let's say. And click OK. So now that inner circle should be defined as part of this. And then I will also create another circle going outwards. And so there's two ways to create the holes on this. As you saw in like the solids tab, there's a hole option where you can just create holes on spots. Since we're starting out with extruding the surface, you can also create the holes within it so that just a part of it isn't extruded. So I'm gonna do another little center diameter circle. Let's call it there. Find these real quick. So this outer one was 205, it said. And call this a little bit smaller. Let's call it 1 maybe. Oh, that's itty bitty. Yeah, let's call it 5 millimeters. And then we can define the distance from the center. So you can drag it around kind of right here. If you want, can say it can be collinear, I believe is the correct one for this. Here. Not sure if that was right. Like I said, it's a little bit different for SolidWorks, so forgive me while I'm learning with you. And then I'm gonna say I want this, yeah, about 97.5 away from the center. Now, you're only drawing one hole because you can actually place the pattern throughout it and it'll automatically space them out for you. It's pretty nice. So I said I was going to touch on this later. So if you go on create, you see mirror, circular pattern, rectangular pattern. This is super handy because then you don't have to say like, oh, I need to find each angle and like repeat each process. I can just select a center that I want this about and select how many times I want it to appear. So if I click circular pattern, it says type full. Objects, objects is going to be the circle itself. That will end up being the hole. And the center point, we're just gonna select the origin for this case. So it has this type, so you click OK. Oof, it was working so much nicer with me last night. Objects, center point. There we go. So you have quantity should automatically appear here. So generally you're gonna see like 4 to 6, I'd say. And notice how like it spaces it out for you. So you don't have to worry about anything. You just need to make sure that it's the right distance from the center when you're defining it. So if I want 6, let's say, I can leave it like that. Looks real pretty. Finish sketch. And then up here in solid, I'm gonna click extrude. Extrude basically, you can like pull up on a surface to make it like a certain thickness from a sketch. Unlike the other options I kind of covered earlier, it's not really for a curved setting. It's more if you just want something like straight brought out. So you usually define it with a surface. So I'm gonna select this top space here as my surface. It's giving me a little red there. I think that's part of how it's defined. If it's an error, then that's probably because I selected the inner circle rather than the outer, and it's confused that the outer is getting included. Either way, this should run. So if you go here under distance, you can select how much you want it up. So if I want it like 3 millimeters, let's say, and if you drag it, you can kind of see that preview as well. Has different ways that you can start the extrude. So if you click offset plane, then it's kind of, the extrude is going to start a certain distance away from it. So if I were to like be like, oh, I want this 10 millimeters up, it's not going to start the extrude until 10 millimeters up. So usually you're going to want offset plane or from object. From object, like you could have sketched this on the ground and then said, oh, I want it coming up from the top of this cone, rather than defining the sketch as the top of the cone. So I'm just going to click profile plane because I already set it up that way. Direction has one side, two sides, symmetric. That's pretty similar to what I was showing you with the shell, where you can kind of choose which direction you want it to go, or if you want it just kind of split in the middle. So like symmetric, it's like in the middle. We're gonna want it one side, extent distance to object. These are more for different applications. So if you say to object, then I could say, oh, I want it extruded to the bottom here. Then if you're making a part, it'll automatically shift if you change the length of that object. So yeah, I want distance, and then you can define the distance. You can define an angle if you would like, but it will be a straight extrude and not a curved, even if it's at an angle. And yeah, it comes with a little operation. So that way, if it's like intersecting or something, you have something there. I'm just gonna click join for this. Click OK. And you have this nice little cone. Now, this comes more into if you're doing FEA and like different types of analysis on this, you'll want to define the materials as well. So let's say I want a paper cone with a painted metal rim. So you can go under bodies, I believe. And select the physical material. You can also change the appearance. So if you're like, oh, I want to keep track of like this object's different from this one, I want this one to appear red and this one to appear blue. We're just gonna start off with physical material. And it has this little pop-up. So yeah, under miscellaneous, you can choose paper and you can just drag that to this. I now realize because I kept that as a separate part, so instead of join, you actually want new body. That'll let you define the material differently. So if I were to right click on this, click physical material, have the pop-up, go down to paper and drag it to, oh my gosh. Just gonna hide this. Drag it to here. It'll make that paper. For the outside, if you wanted it metal, say, I think they have a painted steel option. Yeah, near the bottom. Steel finish, dark gray. Can drag that there. And you kind of get a gist for the appearance, but also if you're doing analysis, then it'll analyze the materials with the data that's in their database. Which is real nice because you can generally like customize those options. So if you're like, oh, my specific aluminum, I've tested it, it has these specs, you can generally change that out. I haven't done a ton of analysis with Fusion, but I know at least SolidWorks works that way, and most CAD software does. So now you have your little paper cone with a metal rim, with whatever material you so selected. Were you guys all able to keep track with that, or is there anything you want me to touch back on?
No, that's all good.
Cool.
Yeah.
I probably will want to go over this like later, so if you could upload it to the Google Drive afterwards.
Yeah, absolutely. And also, like, I might still touch on SolidWorks later for you guys. It's just that, like I said, this was an easier download, so if you didn't have it beforehand, it was quicker to get. It's free for all students, so if you're working with someone at a school who doesn't have a license, I believe it should still be covered. Versus SolidWorks, the school has to have their license. You need to download it on your own with the school's credentials. Yeah. And then I also forgot to mention this at the beginning, but I was thinking of maybe touching on either CAM or analysis next week. I just didn't have enough time to play around with this too much this week on this software. So I want to make sure that I did that justice when I touched on it. Yeah, do you have any questions though about like controls, what different things do, any of that?
No.
Cool. Yeah. And as you delve more into these things, you'll discover that there's a lot of hidden features that maybe you wouldn't have noticed until you had a specific application for it. So like, technically I could have made this into an assembly. I could have created a part for the rim and a part for the cone. And then you would come under this assembly tab.
Yeah.
I'm not a huge fan of their assembly, so I just didn't want to deal with that for just like a quick sketch.
Yeah, Fusion assemblies are a little bit of a mess, but
yeah. Yeah. So I guess I can cover, if you guys are interested, like just some differences between Fusion and SolidWorks that I noticed playing around with this. Because like I said, all CAD software is fundamentally the same in the sense that you're like modeling a 3D object. A lot of the controls are the same. I think basically like the way that it's sorted is the biggest difference here that I've noticed, because you see here it's split into bodies and sketches. SolidWorks, it's more broken down into, you have the body and then each body has the sketch that defined it as like a subcategory for it. The sketch controls are pretty similar. I know SolidWorks also has an easy click for the 3D sketch, which is basically more free drawing in the 3D realm. Like I said, this one spits out a few less errors at you if you're just kind of throwing it together. SolidWorks, you get a lot of errors. That's kind of the way it goes. This is also cloud-based save, so if you like save it, you have all of this. Also with assemblies, usually they're called mates. Here they call them joints. So basically that's almost like constraints actually within the sketch realm. Within the assemblies, you generally have mates between objects. And so that could be like, oh, I want to make sure that this surface sits on this surface, or oh, I want to make sure, like, if you're like, I don't know, have a bolt, let's say, I want the outside of this bolt to line up with the inside of this hole, and I want it to be this deep in the hole. There's a lot you can do with that. Here they just call it by a different name. It pretty much has all the same functions though. So I think that's the biggest transition, is just kind of getting used to the different style, and also of course the bodies versus sketches categories. Also generally within the sketch, remember how here when I was saying, oh, I'm gonna, oh my gosh. Please. Well, anyways, if you remembered, here we go. If you remember within the sketch, you have this project include section. What I've seen, at least on SolidWorks, I can't speak for all softwares, is that you're generally going to have it be called convert entities. It will probably appear less drop-downy like this. You can usually like right click on these and it gives you the or it has like a drop-down folder of some sort for like the different definitions of a circle versus having to click the drop-down to get it each time. Also, the shortcuts are generally a little less intuitive than here. You have like M for move, C for cut, or C for circle, I mean, stuff like that. Austin, you've worked with CAD before, right? Or was I remembering it?
Yeah, never very well, but always, but yeah.
Yeah. So is there anything else that you notice? I'm guessing you've probably worked with more of the AutoCAD region, I could imagine.
No, I did a lot of Fusion.
Fusion? Okay.
I was part of a club that we were Inventor for a while, but that was a mess in terms of keeping files straight. So we moved to Fusion, and it's fine for parts like this, but you start getting into like 200-300 part assemblies, and everything just falls apart. So
yeah,
that's where I definitely recommend SolidWorks.
I think SolidWorks and Creo are the two that I've heard most commonly in industry.
Yeah.
Even with AutoCAD, like I've heard that more with like people who 3D print, like more like kind of hobbyist. I know like some architecture stuff uses AutoCAD.
Yeah.
I don't think I've heard too many companies using it full scale.
No.
And I feel like Fusion, like you'll see that more in like smaller companies. SolidWorks is pretty expensive to support.
Well, SolidWorks is pretty expensive, but it also requires a lot of, like, if you're working on a huge team, it requires a lot of server and data center infrastructure in order to actually store all your files together so that everyone can work on it. Fusion's all cloud-based, and so if you're small, that makes things way nicer.
Yeah. It's definitely very capable for what it is.
Yeah. No, definitely. Absolutely. And it's nice that we can get it for free, too.
Yeah, love that. Love the student discounts and free software. I'm gonna
Ollie,
miss it.
I'm curious, is there a way, so at the beginning of this whole process, I actually made my thing upside down. So I put one, like the smaller plane on the other side, essentially.
Gotcha.
Where you got it. Is there
Yeah.
a way to rotate an entire like grouping?
Yes. I don't know how to do it on here is the problem. I would have to look that up.
Okay.
Um,
I mean, yeah, I figure it's possible. I just don't know.
yeah, you can definitely do it. I think usually, let me see. I'm gonna play around with this. Because usually there's some way to like rotate something. I mean, you could definitely like just change the base sketch. I feel like there should be something to rotate though. Aha. Okay. Fix it out. So if you click on the move option,
Okay.
there's the one within the sketch, but there's also the one under like the solids tab. So you can do it with the body itself. So once again, you would select what type of move object you want. If you want components, bodies, faces, sketch objects. In this case, we would select bodies rather than sketch objects, now that we've extruded them. And then it has translate, rotate, point to position, and free move. So you're gonna wanna rotate that. Axis, I would choose the x-axis. And then you can do 180 degrees. Does that work? Theoretically, that should work. I might have a constraint on here that I don't know about. Actually, it's probably how I define this top.
And then what's the difference between the body's components and sketch objects? Like when you would want to do in this case for bodies?
So for bodies here, I mean, it's kind of like how they broke down the subcategories, right? So the sketches are the shapes, the geometries that you are initially working with. And then the bodies are when you actually turn those shapes into a physical object with thickness and height, all three of the dimensions.
Okay.
Yeah. Quite honestly, I wonder if you could rotate the origin. That might be complicated though. Yeah, I feel like the software is more intuitive if you've never used CAD before. And I've just been like so broken into SolidWorks, like I am not used to changing it. It's coding in a different language.
Yeah, I would agree with that.
It's a much different language. Like I said, the basis is the same, but there's small things that you forget about. different terminology and syntax. Yeah, and I would encourage all of you to like watch YouTube videos. There's a lot of like quick tutorials that just show you like the basic functions. I showed you this at the beginning, but if you go under like this base projects tab and you scroll down a little bit, they have samples for you to work with, little exercises that get you familiar with different capabilities of the software. They also have like their set of forums. I feel like there are very few questions that can be asked that haven't been asked by somebody else. So generally, if you do like a quick Google search, or they have like a quick help tab up here that takes you straight to their site, that usually has an answer. Sometimes if you have a hard time figuring out how to word your question, that might lead to a little bit more digging, but ultimately the answer should be out there somewhere. Alrighty, so I'm probably gonna stop sharing now. I will stop the recording. Farewell, anyone watching this.